Um, I guess we're announcing this on Monday. I guess I officially have joined Spiral then. So, woohoo. But yeah, so we're gonna take like a look at LDK Node today, which is like we're showing. This is LDK, the website, but LDK Node is like a simplified version of it. But there's a lot of people that use LDK in the wild. I used to work on Mutiny, no longer. I guess I used to work on Rust DLC as well. But we're going to be showing off LDK Node, which is like a simplified version. Elias, the node of LDK, or the developer of LDK Node, he's published a release for me last night so we can play with the new stuff. I don't know what the new stuff is, but he said to use the new version, so we're going to do that. But here's the docs. It's pretty simple. But yeah, like the core idea is just like to have like the easiest to use Lightning node to like build yourself. So core idea is like you just build it, put in your parameters, and you can start doing everything. So for today, let me pull up my notes on my phone. So yeah, to start out, we can just do cargo new to build a project. Yo. And we'll do PlebLab. Alrighty. So yeah, that was my demo before. So yeah, the basic thing is you just do cargo new to start any new project, and then we'll open it up here in our IDE. Alrighty. So yeah, when you first start out, this is all you get, hello world. And I mean, you just run it, doing cargo run. We got a hello world. So now we're officially a Rust developer.
Really?
That's all you got to do. I mean, first I guess I should have started. You got to download Rust. So you can go to like, was it rustup.rs, and this will install Rust on your machine and everything. But a lot of operating systems just have it downloaded by default nowadays, so you should be okay. But yeah. So as before, we add LDK node though. To make things simpler, I want to make it like interactive. So what's this dependency called? Rusty line. Basically just want to make like a CLI tool to start out. So to do this, we do look up the docs for this. Or I have it in here. So yeah, this tool, Rusty Line, it's nice for just like making simple, like interactive command line tools instead of just like a one and done kind of tool. So this is like basically like it's creating the object, and then we will read a line and then react to it. So we want to do that multiple times, so we can just put in a loop. And then we need like, the first time I did this, I accidentally just like could never exit it, so we need to do that first. So we will split it up into words. So we can do the line dot trim dot split white space and collect it up. So this will take that line, split it by every space, and then give us like a vector or like an array of every string. And then I guess we need to detect if the words is empty, or let's not do it like that. Is empty, and then if it is, we want to just return and exit. Otherwise, then we want to take like that first word, and then we can just match on it. And yeah, so we can give it an exit condition, and we'll just return as well. Why is this? Oh, I need to. What? Accepted. Oh, it's just mad at us because we didn't. Line unknown command. So yeah, so this is like some basic Rust here. We're taking like a string, splitting it up into every word. If there's nothing in there, we just exit, or we should actually just continue and just retry again. Otherwise, we are taking the first word, and then right now we only have one command, which is exit, which will exit it. So, and then otherwise we just say unknown command. So we can run this now. And so now we have this like little place we can type. So we can like blah, 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 unknown command. Or we do exit, and it'll actually exit. I guess we should also exit on the error case here. But not a huge deal. But yeah, that's super basic Rust. So once we have this kind of stuff here, we can start and adding like LDKs to it. So we can take LDK node and the latest release, let our IDE update that, and then we can start actually playing. So you can go to LDK nodes docs. So they used to have like, use this LDK node builder. So my IDE catch up.
What is it doing right now, Ben?
So my IDE, like when I type in like, I can do like RL dot, or well, it's catching up, but like basically it'll, like right now I get this LDK node, it's like red, and it's just like, it hasn't like read the new library that I just imported. So like now that it's like caught up, I can do like LDK node, and it like has all the autofills for me. So yeah, it's just like your IDE is just like.
What is that IDE?
This is Rust Rover. It's like IntelliJ's version of like a Rust IDE. What up, Joe? So yeah, this is like basic stuff. So we can like start building the node now. So yeah, we want to do that before the thing. So we can do like LDK node, builder new. So I need this. And then let's take a look at the docs. Okay. So we need to give it a network. So we're going to use MediaNet. So I'll do Signet. Sets. Let's see, we need a change. We need a, like, so we need to set an Explorer sources, like where we get our blockchain data. And then we will use, let's use MediaNet again. Why are we getting an error? Oh, we need a config. I'll skip that. And then what's the last thing we have to set? Oh, a gossip sync source. Let's see, I wrote this down in a separate project.
Why do you have a string dot to string?
Okay, I can explain that, yeah. So the question was, why do we have a string dot to string? Let me put this in first.
Those mics are live so they can hear you.
Oh, okay.
Yeah.
So there's actually, Rust has like two string types. There's, I can do like, let hello, and we have like @stir equals blah, blah, blah. And then like let world is a string, and it's da 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 dot to string. So there's like, the core ideas here is just like, this hello is like a reference to like literally like this part of the program, which like when you compile it, this like string, this like actual like string literal will be like compiled into the program, and we have a reference to like that piece of memory, versus like this world string right here is like a string like almost like object that's like has a lot more like, it's like a thing that we're actually like saving in like real memory, and it's moving around, versus like this is like a part of the program. So like @stir is like you need to like, normally it's like you're passing a reference. So like if this was an @stir in here, then they can't save it to their object like they do here, because you're just having a reference that you're like then need to pass around forever. versus like the string, then they can like move it around and however they need. Like we'll get into like a borrow checker a little bit, but this is, yeah, I guess that's kind of a little bit of an intro, but yeah, like one of the core features of Rust is like managing memory safely. Like with like C, you have like double freeze and scary stuff like that, or you can use like JavaScript where there's just there's garbage collection. It handles it for you. Rust is like trying to do it where it's like it's safe but also efficient. Where like most of the other languages are just like it's unsafe but you do it yourself, so it can be efficient, or it's safe but inefficient because you're using a garbage collection. And Rust tries to like do it the correct way, where it's like safe and efficient. It's just you add more rules, and it makes some things harder, but it also makes things a lot more powerful. So, so we got basic things set up here. What up, guys? So what's next? So yeah, then we just you can just build our node. So yeah, we just build it, and then we can start it. And then just to start out, we can just do a simple command. We'll do like address, and then we could do like node dot, what is it, on-chain, how do they get an address? On-chain payment dot new address. And then I'll just print line that. There we go. So now if we run it, so this is the fun part about Rust, is you get a million dependencies and they all take forever to compile, but it's worth it. Are you gonna follow along?
Yeah, I'm looking through the live stream.
Okay.
Is there a live stream?
No, we'll do that later.
You got a repo or something?
I can just like copy paste this to you if you want to just catch up.
Sure. Yeah.
Okay.
This is just your main.
I'll do it in Slack. Hopefully nothing bad shows up. I got the PlebLab Slack open. Let's see. Does this work? So yeah, boom, we got an address. My laptop. Is there an outlet? Sorry.
So now the node is actually running. Like you could send the payment to that address, and it would
Yeah.
show up technically.
Yeah, we got to implement the balance part. I guess I need to implement to what's it called? Node dot stop. Yeah. So this should be breaks.
I'm opening up the Replit.
Okay.
Yeah, I was like, screw this local environment. I'm just gonna like paste your code and click run.
Based.
It's installing the dependencies.
All right, I'll wait for you to catch up, and then we can keep going.
So what it's doing right now is it's installing the node, or it's running the node, installing the node, creating the network.
So yeah, we're just like basically like we build the node here of like this is what I want in my node, which is just like basic parameters. We start it up, and then we basically just like now it's like running, and then we're just like waiting for commands of what to do. So all I have right now is like give me an address, but we'll add more. someone says exit, then we stop the node. That's about it.
You can go ahead.
Okay. We'll try to get balance now. So yeah, we can see if we actually have money. So we can do what balance. How do we get balance? Let's balance this. Here we go. And then we could just do front line wire balance. Let's see. So exit. All right, so now we have no balance, but that's expected. So now we can do address, and then go to our Uninet, what is it, faucet? So log in. Uh-oh, did we break the faucet? Oh no. What happened?
It might be, could be Wi-Fi.
No, I need to. Fuck me. Well, I can just,
Did you guys take it down or something?
no. I was testing it the other day and it was working.
Oh, shit. Yeah, it's broken for me too.
Fuck, okay. Well, deal with,
Take all this out, don't worry.
It's probably like your GitHub token expires.
oh, maybe. I can just send from I have root access to the faucet, thankfully, so I'll fund it myself. So it's send to address. Is it this? Boom, okay. So you can look at the transaction. All right, big consolidation right there. Once this gets confirmed, then we can see if it shows up in our balance. Here. Where's my blocks? There it is, alrighty. So now let's do balance again. Let's see. It's not showing up yet. Let's see. I wonder, do we need to sync it or something? So like node dot. Here we go. Okay. So we need to call sync every so often. So we can do node dot sync wallets. And then does this give us anything? So yeah, this is just returning like an empty type. So it does stuff. So we can then just print out like line synced. Shoot. Okay, so one thing I just realized after I stopped it is we're not. Well, I don't know what's happening to the seed if it's the same seed every time. I guess I probably have some database somewhere that's being picked by default, but is that in here? Maybe? I don't know. Let's see.
If you make a new address, if the address is the same, it should be.
Well, there's our balance. So something showed up. So yeah, but now we have a sync command too, so we can resync. And boom. Cool. What else? What's next? So I guess, yeah, now we have this. We can start we have on-chain funds. We can start opening channels. So we can just add a open command, and then do open channel. So this is going to take some parameters. We need a node ID. We need a, what else do we need? The address connect to, the amount, and the push. Okay. So address equals boom. Amount. And we're not going to do a push amount, but that's okay. And what does this return for us? Channel ID. So we actually have to parse these things. So we can just get that from this like list of words we have. So we'll say, I guess we need to first check like if words dot length is greater than or equal or less than what. So we have the first word 0, and then for open, and then we need a node ID, address, and amount. So 4. So if it's less than 4, then we error. Continue. Okay, so this node ID will be our first word. So we can do like word 1, and then we'll just need to turn this. So this is like going to be like, again, like an at stir, but we need to turn this into a public key type. So we can just do public key. It's going to be the secp public key from string, and boom. We just need to import public string. And we can unwrap that. And then we need to do the same thing for the address. This is a socket address from string, and then this is words 2. Unwrap, and then our amount is a what is it? It's just a U64. So I think this we do a U64 from string words 3. And why does this give me an error? It takes 5 parameters. What am I missing? 1, 2, 3. Oh, and the channel config. You can skip that one too, though. Boom. And then I think this will start the process of an opening channel, but there's basically this LDK node doesn't like this will just like kick off the channel if you read the docs. I guess it just doesn't explicitly say, but there's as well the event manager in here, which gives us these events. So let's see what they do. So you have like all these payment ones, payment failed, payment received, forwarding ones. We have one to claim, and so yeah, we get a channel ready. So a channel pending. So this will be like when the actual channel starts being opened, we'll get this event. So what we'll need to do is have this running in the background. So this is going to complicate our code a whole bunch actually. So if we want to add background process, I guess we can actually do it kind of simply, but we need to basically start a background thread now. So to do that, we do, spawn. We need to do one thing first. So first is actually let's get the error first, and I can show you guys. So when you do the spawn, you're basically creating a new thread, and this will, the docs are pretty complicated, but it's basically just like creating a thing, and we can give things to this. So I can put the node in here and do next event, loop on this, or I guess we do let's just loop. And we can then like start processing every kind of event. The thing is, let's make this not compile. What? What's expected closure found? Oh, I need to do that. What am I doing wrong? Okay, so yeah, this is the error I was expecting. Okay. So we now have, we need to do this move basically because like when we first, if I don't have this move, it's saying, let's see if we can get the actual error. Like closure may outlive the current function. It borrows node, which is owned by the current function. So we have this node here and we then say like, hey, new thread, you can use the node and process events. The problem is the node is currently owned by the main thread, not this new one we're spawning. So we have to tell it to move it. But this is going to give a new error where now all these are throwing an error saying like, what the hell, you know, value is being used after it's moved. So we said like, hey, this thread now owns the node. But then we're going back to the main thread saying like, hey, I want to use it again. And this is like kind of what the borrow checker is like enforcing is that like we need to use the manage. We need to manage the memory properly. The way to fix this is just basically put an arc around it. So arc stands for atomic reference counter. Basically, it just says like this arc now owns the node, and then this can be passed around much more easily. So then we can do like events node, and let's create node dot clone. So now we can create a copy of it and hand it over to this thread. So now we have a copy of our node, and that can now run safely in this thread and still be used down here.
So explain that arc again, Ben. So you said it's like a.
Let's see if the doc now these.
It's like a grouping or something. It's like a.
I mean, so basically, like the problem was like, yeah, we can't have this node be owned by multiple things. Or multiple threads safely. So basically what this because the problem with like if I don't have this arc, then for one we can't clone it. So then we have to give it to either like one thread, this background thread, or a main thread. But we actually do want to have it in multiple threads. So we need to like have a way to safely give it to both. And basically the arc is basically what it's doing is it's an atomic reference counter. So it has a counter for like how many different places own this node. And so then once that goes to 0, then it can safely drop it. And when it's not at 0, then it knows, okay, multiple things own this. We need to keep it alive and keep it running kind of thing. Yeah, it's like when you write a lot of Rust code, you end up just putting arcs in a lot of different places. But at least we're running complicated Rust code. But yeah, I mean, arc is basically just like your cheat code for like getting around the like what's it called, the borrow checker and stuff sometimes. But yeah, that's what we need to do here is to allow it to give it to multiple threads. But yeah, now that we have a borrow check or a background thread, we can now process these events. So we can go and what's our first event type? Let's see. Well, let's do channel pending so we can see that one. So we can take a channel pending and so let's see. MyD filled it all out nicely for us. But yeah, let's do continue here. And then we need to bring back the other ones. We'll just continue on. So we have a channel pending, and for now, I don't think we need to react to it, right? So we can just print out. Print line. Channel pending. And we'll do the transaction ID for us. So there, let's see if we can open a channel now. I think that'll all work. I guess we can, we'll do a print here. Channel opening. And give it that channel ID here. It's not. There we go. Okay. So let's see. See, I'm getting a bunch of warnings just because I'm not using all this data. We can clean that up by just doing it like this. But I'll keep it there for now because maybe we'll use it later. So let's make sure we have a balance. Still got our sats. So then we can do open. And then how do we format this again? We do, so the node ID, address, amount, and channel ID. So I've accessed faucet. Let's open up to the faucet lightning node. So we can do channel ID, or the node ID, socket address, and then our amount. Let's do 50,000 sats. Channel opening, all right. Oh, so we got a bunch of channel pending events. Yeah, we'll see. I mean, I guess we should also add our.
Are those duplicate events?
Yeah, I guess so. Yeah, let's see. Okay. Oh, okay. So we need to call this node event handled so it stops giving it to us. So we can do that. I guess we just, well, yeah. And then let's also add handling for, what's it called? Let's do it like this. For when it gets confirmed. Channel ready. And we can, what else does this give us? So you can print line, channel ready, and we'll just do the channel ID, I guess. Boom. And then we need to call that event handled. Oh, I did. We're using the wrong node type here, see? Okay, boom. So we got that channel pending immediately, and then a channel ready. And so that means our thing must be confirmed. Or is it in here? And there's our channel. So we have a channel, so if we do balance, yeah, we now have less on-chain, but now we have these lightning balances. So the total lightning sats, just under 50K. We have the reserve sats, and then, all our fancy lightning claimable stuff.
Oh, wow.
So we have a basic lightning node working. We can try to send a payment now. I was thinking instead of trying to do a normal payment, we add LN URL support first, though, just for fun. So we can just use the LN URL. Oh wait, what's it? I've created the library. What is it called? LN URL rs. 0.9, and we'll download download that. Okay. So we can do send, and then so this will need an amount and as well as like a lightning address. So I guess we'll have 3. So we need what lightning address, an adder, and then we can do lightning address from a string. Yeah, that'll be that word's 1 again. And then amount, we can just copy paste from up here again. This is where it's 2. And then we'll do, so we need to actually get the invoice from this lightning address. So for that, we need to, we need like a lightning address, like kind of client. So we'll do LNURL builder, or I guess maybe blocking client. LNURL builder. Okay. Yeah, this is not the cleanest because we try to support all different use cases for this. So the building of the API can be kind of ugly, but what do we need to give this? Okay, builder default build blocking. There we go. Okay. So yeah, this has like 2 different types. There's blocking and async. The way this is currently working, LDK node is all like blocking. It doesn't use async stuff, so we have to use the blocking version. But that's fine. And so now we have this client, and we can do like client dot like get invoice, and or we'll start with list. There's something else we do first, but yeah. So we have this lightning address, and then we'll need to turn it into an LNURL. So we just do lightning address dot LNURL. And then we need to take our client, and let's see. So just make request, yeah. Yeah. So we got to make this request. So basically, with an LNURL, you don't know if it's like an LNURL pay or withdrawal or channel or any of those until you call on it first. So we just need to do this LNURL dot URL, and we'll get a response, and we can match on this. And we have like a few different outcomes that can happen here. So if we get a withdrawal or a channel response, that's not what we wanted from a lightning address. So we should just like print error, wrong response, and then we'll continue on. Do the same thing for this one. But if we get a pay response, that's what we want. So we can process that. So this pay response, let's see if we can like go look at it. It's got a callback string, a max sendable, min sendable, tag, metadata, and then some like stuff for like zaps. But we just need to make a payment. So what we should do is check that our amount is within our min and max sendable, and then we can go ahead and pay. So you can say like. And I guess we need to account to these min and max sendables are in millisatoshis, not satoshis, so we need to process for that. So if we have like if pay dot max sendable is like greater than our amount times 1,000, right? Or no, be less. If this is greater, then we need to throw an error. Good. Nope. Valid amount. And then as well, or pay dot insendable is greater than, or that seems wrong. Is that right? I hate Boolean math. That was greater than that. This is wrong. We'll see. I just continue. Otherwise, we'll pay it. So we'll do lightning dot get invoice, give it that pay, and then we need to give it our amount, millisats, and we're not going to zap, so we'll skip those two. Unwrap that, and we'll have our invoice. So now we have an invoice. We can give that to our node. Just say pay. So do bolt 11 payment, and how do we pay? Send. Here we go. Send our invoice. Dot. Oh, do we need to parse it? Okay, so yeah. So this is like this LNURL pay invoice that we get. It just has a normal string on it. So we need to like parse this into the actual invoice type. So we'll just do bolt 11 invoice from string invoice dot. Give that to here. What else do we need to give it? Sending parameters, we can skip that. And unwrap. Let's see. What's that gives us? It just gives us a payment ID. So we'll also want to process that event. So we have what? Payment claimable, payment forwarded, payment failed. So yeah, we have these payment successful and payment failed. So we basically going to have a response for those. So we'll do some event payment successful. Autofill all that. And we'll print payment success. Give it that payment ID. I'll do the same thing for failed. Or just not copy paste. Sad face. Alrighty. Let's see if that works. I guess we need to just do a print here. Let's do payment started.
Okay, this is all for the LNURL stuff?
So we had like, let's see, this code here is like getting this the LNURL. So like here we like parse the lightning address, and then we turn it into an LNURL, and then we basically process like turn that LNURL into an invoice, and then here we just have like 2 lines where we just parse the invoice and then send the payment. So LDK LDK node is doing a lot of our heavy lifting here of like doing all this fancy stuff to get a payment to go out. But yeah.
Where did you end up getting your mutiny net cords?
Oh, I just logged into the faucet. Do you want some?
Yeah.
If you want to send me,
Send me an address.
yeah. Our payments work now. So hopefully our channel still exists after closing and reopening. It should, but we'll see. Come on.
Give us a sense. We're like at, I mean, I'm at 114 lines. I don't know what you're at, but how much would this
162.
be if we were not using LDK?
If we're using raw LDK, this would be like we probably wouldn't get a node started today.
Really?
Yeah, I mean you can like copy paste the sample, but if you want to do anything custom, it's like you have a million different things you need to configure and like set up. It's a lot. Okay, so we got it running. So we can now do, let's check our balance, make sure everything's still there. So yeah, we still got this. So our on-chain and our lightning balances. So should be good to send. So our faucet can receive money, hopefully. So what do we call it? Just send lightning address, and we'll send it 1,000 sats. Oh, okay. So yeah, we got it to work. I forgot to put that event handled though. So there we go. We can do it again though. We'll see. All right. Send. Oh. Maybe we'll send. Let's do 500 sats this time. It's different. Boom. Sent. All right. So we got payments working. I guess the last thing to do would be receives. So let's see. We do receive. So basically just like we want to get an invoice, and then as well we want to print out when we actually receive. So let's do the processing of the receive first. So it's what I think it's payment claimable or payment received. What does this give us? So yeah, we can do like rent line received. We'll have that amount MSATs. And print that out. And then I think we need to process this payment claimable as well. We'll see. So yeah, we can do claimable payment. Just remember to put these here, but do we need to? Let's see, like claim a payment manually. I don't remember. Maybe it's in the docs. Okay, claim for hash. What's this need to call? Is it in here? Here we go. So we have to give it the payment hash, the amount, what's that called? Claimable amount, and the pre-image. Where do we get the pre-image? Is that from? Maybe this is only for custom payments. I think we can be safe without this. We'll see. Oh. So yeah, all right. So now we got to receive. So this is pretty easy. We just do like node dot Volt11 payment dot receive. We need an amount. So again, we'll need to parse that from the user. So this we only need one parameter. And we can copy paste this again. And let's see. So yeah, it takes an amount, a description, and expiry. I guess we can take a description from the user too. So let's see. That's like their formatted version of it. So we'll do that. Yeah, they have, so yeah, Bolt's 11 invoices can have like two different types of descriptions. It's either like just a raw string or a hash. Or just needs a string because that's easier. But yeah, the type is kind of complicated how they do it here, but we can let's see. It's not gonna be read. Yeah, maybe let's do that. We'll just default it. That'll be easier. Mount. Where are they putting their docs? Is that there? Oh, they do not. Bastards. Okay. And then a expiry. Let's do it. Yeah, do an hour. We just need to that there. Unwrap it. Okay, so this will give us an invoice. So we just need to print out our invoice now. Let's do it like this. Boom. So now we can call receive, give it an amount, it'll give us an invoice. And then when we actually receive a payment, we should print out received it. So we'll see. I guess one thing, so yeah, this amount, is this in MSATs? So yeah, we need to divide this by 1,000 so it can be, or multiply by 1,000 so it's in SATs. So let's exit and restart this. Cool. So we still got our balances. We're at, let's see, what's our lightning balance? Right here, 49,075, or almost 500,000. So we'll do receive for hard sats. Oh, invalid syntax. Oh. Oops. Receive hard sats. All right, got our invoice. So then we can go into the faucet and pay that. It's 100 cents. Failed.
No route.
No route. Oh, we still. How much did we send out? We sent like 1,000. Okay.
And then you sent 500, or you sent back 500.
So yeah, we might need to send more out to get some inbound liquidity, maybe.
Or I think initially you sent like 50,000 or something.
So let's just see. Okay. So now, let's see. This doesn't list our inbound, sadly, but let's do that again. Refund. Here I have it here. All right, now we definitely have some inbound. Let's see if we can pay the invoice now. There, now it went through. There we go. So received, however many millisats, 100 sats. So our balance. So yeah, we went from here to here. So we got 100 sats. Cool. We can receive sats.
So technically, you're ready to build a front end for this if you wanted to, huh?
Pretty much, yeah. I mean, this is like We got opening channel, send, receive. It's basically a lightning channel or a lightning node.
Under an hour?
Yeah.
That's amazing.
So yeah, the only other thing that they have that we could play with is I don't know, there's a lot of other things, but the cool thing is they have the LSP integration already as well.
Oh, really? We can select an LSP?
So you have to
Break it
like,
down?
yeah, I mean, so we'd have to like hard code it in, but so yeah, we can do like, let's see, a key, string, size, and then.
Do they give you the option for the different LSPs that are out there, or how would that work then?
So yeah, this is only with using the LSPS2 spec. So I think Zeus might have implemented this by now.
Oh, okay.
But yeah, C equals was implementing this, but I don't think they exist anymore, sadly. And then I don't know. Maybe the BitKit guys are using this, but yeah, it's not.
Because Albi uses it, doesn't it?
Maybe Albi does. Yeah, Albi uses LDK nodes, so I would assume they're using this actually. Yeah.
Bullish.
And we need our token. So yeah, we just need to say like, okay, this is our LSP. This is the node ID, the public key of it. This is the like IP address to connect to, and then this is optional, but this LSP has a set where you need like a token to say like, this is me. This can be like either like a referral token where like they split fees with people, or just like a secret login token kind of thing. But now that we have an LSP selected, I think we can do is, so we can do a different kind of receipt. We can do like, I do it up here. See, we can do like LSP receive, and we'll do the same thing again, but this time instead of calling a receive here, I think we do, what's it called? Let me look. He sent me on Discord. I don't want to open up Discord on here though. Receive via JIT channel. What the hell? Oh, here it is. Receive via JIT channel. So yeah, so now we're gonna receive with the just-in-time channel. So we can do the same thing, amount, and
I can't believe this is all becoming a reality now.
oh yeah.
I feel like you guys have been talking about this for decades.
Lightning's not even a decade old.
No, but I mean, like, I feel like you guys have been talking about this for like years, dude.
Yeah, I mean it's cool. Like
You guys were
like the
arguing about this for like a few years, dude. You just got annoying after.
yeah. I mean like the Lightning spec has been pretty stable for the last few years. I mean we've had like Bolt 12 and stuff be added, but now it's like.
For reality.
Well, now that like Lightning is pretty stable, it's like now we're adding in all of the, we're like specifying all the higher level things around it. So now we have like a spec around the LSPs and stuff like that. So yeah, we added this. The rest of the stuff should just be handled automatically. So we should, let's see, we'll restart. This time we should like get a payment received event. And then we should as well immediately get like a channel pending event, and then eventually a channel ready. So we'll see if it works. We get that. Oh, do I not? Okay, we're calling it still. Okay. So let's see. We do. What do we call it? LSP receive. And then we'll do it for, let's say, 50K. Got our invoice. And we'll go over here and pay it. Boom. Okay, so received it. Did we get a new channel? I don't know if we did. guess we should add a
Another event of some sort.
we should add a channels whoops, a channels command so we can see our channels. So we don't need any parameters for this, so we just do a node dot was it like list channels, and we can just print those out. Go away. We got that event. That's weird. We're getting that event multiple times. Oh, channels. Okay. Is there two here? This is kind of hard to read. I'm just gonna, let's just do this. Instead of printing out all the channels, we'll just say channels dot length. Oh. Okay, so we still only have one channel. So my assumption is this thing is smarter. So this used the way before when I've used this, it would always create a new channel every time you call this receive with JIT channel. I think they made it smarter where now it won't do that every time, and it'll only open the channel when you actually need a new channel. So I think that just means we need to do like a bigger amount. So let's just like receive 1,000,000 sats. 1, 2, 3, 1, 2, 3, right? That's 1,000,000. Oh. Liquidity request failed. Okay. So we asked for too much. So let's do 500 million or 500,000. LSP receive 500. Okay, there we go. Oh. Okay, so there we go. So we got a channel pending, a channel ready, and then we received our money. So yeah, so now this like, I opened a channel and it was 0 comp, so it was immediately ready.
Oh.
And then we got our money. And so yeah, we asked for 500K stats, but we got 1,000 less. That's because, or 10,000 less because,
LSP.
yeah, the LSP fees. So let's see, we can probably find it in here, yeah. So here's our channel being created.
Oh, you're right there.
Yeah, so yeah, you can see like, so we asked for 500K, but it's a 1,000,000 sat channel, I guess. So it's, now we started out with a balanced channel, which is pretty nice. So we can check our balance and our channels. We got 2 channels. Boom.
That makes sense. Cool.
So I think that's all I really had written down for what we could cover.
That's cool.
Yeah.
Do you
That's
have any questions?
full Lightning node. Yeah, I'll put this on my GitHub if people want to play with it. Copy paste it.
Can you send me your node ID? I want to try and open up a channel.
Oh, that's a good idea. I need to add a command for getting my node ID.
Oh, yeah.
Well,
Or like a get info or what?
I don't think you'll be able to open a channel to me because this isn't public facing. Can't
Yeah,
connect
we're
to
on
it.
local.
Yeah, we're on Wi-Fi.
Why would
Yeah,
someone
then
want
go.
to make a wallet? Like, during the NFT craze, everybody wanted to make a wallet, and I'm like, nobody needs a fucking wallet.
Well, yeah, I mean, making a wallet is a dangerous business. I've been there. But, I mean, the goal is just, like, have tools so people can do it.
Cool. That's what's up.
Yeah.
So if somebody wants to make a Bitcoin wallet or a Lightning wallet, and I'm like, you have no fucking clue which you're getting into, but go check out Ben's thing, you can get started.
Yeah, I mean, kind of the idea is, yeah, like, lowering the barrier to entry to creating a wallet. So, like, oh, I want to create a Lightning wallet. You don't have to go, like, read the bolts and, like, learn how, onion routing works. You just call send payment, and that part is all handled for you.
today we'll do a vibe coding hackathon, and you can use the same GitHub repo to submit your hackathon project to win 200K
No,
sats.
there we go. Okay.
So, yeah, come for that.
You think this could win 200K sats?
I don't know, if that has a nice front end.
Yeah,
Well, then no.
I know somebody, we can make a vibe wallet.
There we go.
There you go.
Well, and too, like what Ben is writing here is really concise. If you go ask, like, like cursor agent to go do this, like implement my receive,
Mm-hmm.
this would be hundreds of lines.
Yeah. Yeah, this is only, 218 lines for the whole Lightning node. And I mean, we could trim it down as well if we wanted.
Yeah, but that's amazing.
Have you ever tested any type of escrow event in between the sender and the receiver?
Can't really do that with Lightning. There's this company called Lightning Escrow, but the problem is like Lightning payments, when you lock it up, they you kind of like are like DOSing the network by locking up payments, because everyone has to hold that payment, and then if it expires, then they have to like force close their channel, and it's expensive. So you can't really do escrow on Lightning, at least safely.
Is it something people are working on?
It's just the limit of the system. It's not really fixable.
Gotcha.
Yeah.
Can you show me where you define your LURL, like client again?
Right here.
LURL builder default.
I guess we can do one last thing, kind of for more Rust intro stuff, is like, you can see here, like basically I'm doing unwrap like, how many times? 29 times. Like, someone gave me this code, I would immediately knack it, be like, why are you unwrapping everything? So basically, like Rust has this nice result type. It's basically like the result is an OK or an error. It's basically like a way to handle errors nicely. But one of the hard things is like, okay, so like this is gonna have, this error has a error type of default history versus like this thing has a, let's see if it gives me the error type. Yeah, this has like the LNURL error, and then where's another nrap? So yeah, this like socket address has its own parsing error and like all this stuff. So we kind of need to like have a unified way to handle that. The cheating way is using this library called anyhow, and then you would just make your return result anyhow result, and so now we can change all these unwraps to question marks, and then it'll basically it'll turn this question mark basically says like, if it's an error, return that error and convert it into my error type. If it's an OK, just continue on. But normally, like, you don't always want to do that, because like if like using anyhow is fine for like a small like application like this, but I guess we need to return OK at the end too. Yeah, it's fine for like a small application like this, but like for like long-term projects or things where it's like you're an open source library where people are depending on you and they don't want to have to use your anyhow type, it's not the best. So normally what you do is like create your own error type, and then you just encapsulate things. So we would do our own results with our error, and then we would start like, see now we get these errors of like, we need to implement debug for that, I think. So yeah. So we have our own error type. So, but now we get errors here of like, we can't convert this rusty line error into our new error type. So we need to like basically define how to do that. So one way is just doing like, let's just do like default. We could like map this error into our own error type using like default here. Or what we can do is do like like we implement from, so we do like a rusty line. Was it their error type? Is it like this? Yeah. And then we can like create an error type like rusty line error, and we do it like this, and then we don't need this. So now we have this conversion here, so we don't need this like map error. Just our question mark will do it automatically now. And you can like, I mean, this is like a terrible version of an error. We can show like, let's see, LDK will have a good one, or maybe what's something I have in here. Let's do like Rust Lightning. Here we go. So you can go to raw LDK and find an error type. And oh, my thing's gonna be slow. We'll see if you can find one of their error types. Oh, here we go. Okay, so yeah. It's like they have for parsing a Bolt 11 invoice, like all these different kinds of errors. So they can like manually fix and like figure out how they want to convert to things. And this is nice. This is kind of like the way they do it, where they have like all these like internal errors that could happen. You as well can have errors where I can show the for what's it called? Oh, this is the wrong project. For like our ln URL error, we have like our error type in here is a lot more complex. So we have like these internal error types, just like invalid lightning address and stuff like that. But then we also just like wrap all the different errors that like the libraries we're using could use. So like, if we couldn't decode the JSON, we just say it's a JSON error, and we would take Serde, the JSON library's error, and say here it is. So then they can handle it themselves. So you kind of can get this like, you kind of like start wrapping tons of different error types, but it lets you have like really clean ways of knowing like exactly how this thing failed. So like, so the problem with sometimes is you just get like, say using JavaScript, you just get like a string of like, this thing failed, and then you like are either parsing that string in your code, being like, this is how it failed, or you're just printing that string to the user. It can be really ugly. So this allows you to like have extremely defined like what your error is, and like all the way down to like exactly which library failed, and you can see like you can handle that exactly how you need to in whatever way you need to. So sometimes it is, yeah, just print the string you give to the user, but otherwise it can be like, oh, in this exact failure, that just means I need to like edit the JSON or ignore that thing, and then we can handle it correctly. So it gives you like really fine-grained control of exactly what's happening. But I'll use anyhow for here since it's cleaner.
Yeah, it feels very precise.
Yeah. That's mostly it.
Cool.
But yeah,
Thanks, Ben.
thank
Appreciate
you.
it.